Okie dokes. Now let us do Euclidean geometry question. Okay, this is Euclidean geometry question. Now let us read the statement together before we can solve these questions. Okay. Now 9.2, it says in the figure, AB is a diameter of the circle. The tangent to the circle at D meets AB produced at C. The bisector of angle C cuts DB at E and meets AB at F. The radius of the circle is 3 units and the length of CD is 4 units. And then you are also provided with a diagram. Guys, you are given the statement and the diagram. So make sure that everything that is not indicated on your diagram but you have been told on your statement, make sure that you utilize that information onto your diagram. Okay, now let us start. They said to us AB is a diameter of the circle. That's very important, meaning length AB is a diameter of the circle, and then we know that diameter, it is made up of 2 radii, meaning the tangent to the circle at D meets. Now for a fact that this is a tangent at the point D, for a fact that this is a tangent, I always tell my learners that think of tan-chord theorem. Immediately when you are told that the line is a tangent, think of tan-chord theorem, and again think of axiom number 7, which says radius is perpendicular to the tangent. Okay, if you have a line that is drawn from center to that tangent, think of that axiom that says they act perpendicular to one another. Okay, for a fact that this is a tangent. And then again, the most important thing they say to us, the bisector of angle C, meaning this line, which is called the line, you can name it line CE or you can name it line CF. It's a bisector, meaning it cuts angle C into 2 equal angles. That means angle C1 will be equals to angle C2, okay? Because we have a bisector which cuts angle C into 2 equal angles. That's very important, which was not indicated, but we indicate it now on our diagram. And therefore the radius of the circle is 3 units. Remember, we were told that AB is a diameter, but now for a fact that we are now told that the radius of the circle is 3 units, meaning line from center to the circumference of the circle is 3 units. Do not forget, diameter is twice radius, meaning our diameter, which is length AB, will be 6, okay, because it's supposed to be 3 plus 3, which is a complete diameter made up by 2 radii, and therefore the length of CD is equals to 4 units. Go to your diagram, go check where is CD located. This is length CD, meaning the length of CD is equals to 4 units. That's very important to indicate this information. Okay, now this is the only things that are provided to us. Okay, we're gonna use this information to solve these questions. Now let us start to solve question number 1, which is 9.2.1. Now 9.2.1, they say to us, prove that triangle DBC is similar to triangle ADC. You go to a diagram, you want those triangles that they are talking about, triangle DBC. This is D, this is B, and this is C, right? And then triangle ADC, this is A, this is D, and this is C, meaning it's a bigger triangle. And then triangle DBC is within triangle D, is within triangle ADC. Okay, now when we prove similarity, we use equiangular, meaning we prove using the interior angles that they are equal in magnitude. But now let us try to prove this question. Okay, now to answer question number 9.2.1, you are going to say in triangle DBC and triangle ADC, what is happening in these two triangles? We are going to prove similarity. We are going to say, look, triangle DBC, this triangle, it has an angle which is called angle C. D angle CB, D angle CB is equals to, look, D angle CB from this triangle is equals to the very same angle for the bigger triangle, which is called triangle ADC. Triangle ADC, they share angle C as a common angle, meaning it's the same as D angle CA, and then we write the reason, it's common. Okay, we write the reason is common. Why we say those two angles are equal? Because it's a common angle. And therefore another angle that we are going to use, we start with this triangle. Okay, we start with triangle DBC. Triangle DBC, it has this angle which is called angle D1. Okay, meaning it has this angle which is called angle D1. Now angle D1 is going to be equals to angle A. Remember, what did I say to you? For a fact that you were told this is a tangent, think of a tangent theorem. And this triangle right here, the vertices of this triangle are the circumference of the circle. So we are safe to say this is a tangent theorem. Tangent, chord. This is a diameter, this is a chord, meaning it's a tangent theorem, okay? So we are going to say from this triangle, we're going to say angle D1 from triangle DBC, which is D1, is equals to angle A from triangle ADC, because that's where we want to prove similarity. You're going to say is equals to angle A. What is the reason? It's a tan chord theorem. Okay, that's how you write it. And therefore remember, when we prove similarity, we used three interior angles, which is equiangular angle. And therefore you are going to say from triangle DBC, this angle, which is angle B, we're going to call it D angle BC. D angle BC is equals to how much? Let's try to prove this one. Is equals to how much? Is equals to this angle. We're going to the whole angle of triangle ADC. The whole angle of triangle ADC. We're going to say is equals to A angle DC, which is the third remaining angles of triangles. Okay. Now we conclude by saying therefore triangle DBC is similar to triangle ADC. Why? Because we used angle. That's how you prove your similarity. Now we move to question number 2.2. 2.2, it says to us calculate the length of BC. Okay, calculate the length of BC for 6 marks. That's a lot of marks. So calculate the length of BC. Now this is what we are basically looking for. Okay, this is what we are basically looking for on our diagram. But now the very same length that you are calculating, where is it located? It is actually located on triangle DBC. And remember, this triangle, which is called triangle DBC, we have just proved that this triangle is similar to the other triangle, which is called triangle ADC. Now for a fact that this is the magnitude that we want to determine, the magnitude, think of these two triangles that we have just proved similarity onto. And besides that, the triangles that we have proved similarity onto, they are the ones that have magnitude, like CD, which is a common side for two triangles, for triangle DBC, CD, and again for triangle ADC, CB is a common side. So these two triangles, they have side which has magnitude. Same applies to AB. Remember, AB, it was provided to us to be equals to 6, because remember we were told that radius is 3 units. So because now we prove similarity between these two triangles, we're gonna use what? We're gonna use that theorem, the equiangular theorem, that these triangles have the same proportion. They are in the same proportion. Now to calculate the length of BC, you know what I love to do, ne? I would love to extract this, because that's how I taught my learners. We extract those triangles that we have just proved similarity onto. Now let us try to extract them. Now let us extract the triangle DBC. Triangle DBC is something that just looks like this. This is D, this is B, and this is C. And therefore let's extract triangle ADC. Let us extract that triangle. It's a triangle that looks like this. So remember, this is A, this is D, and this is C, right? And then remember, we have proved that this angle right here, which was angle D1, we have proved it that is equals to this angle, right? And then we have also proved that this angle right here, which is angle C, is equals to this angle right here, which is angle C, that we said is common from 9.2.1. And therefore we said that this most definitely is equals to that with which is the third remaining angle, okay? And therefore, what is the magnitude of CD? We said CD, it was provided to us, is equals to 4, and then CD also here is going to be 4. It's a common side for both triangles. And therefore, remember, AB, it was given to be 6, but we don't have AB onto these two triangles. We just have AC. And AC, it is made up of what we are looking for plus what it is provided. You get my point, right? Meaning in this case, AC is equals to BC, which is what you're looking for, plus 6, this length, which is CA, or you can simply call it an AC. Right. Now, because we are looking for CB, remember, let me just solve it over this page, okay, so that I cannot confuse you. Let us determine the length of BC for 6 marks now. Now, BC, this is what we are basically looking for, right? So, because we are looking for BC, we're going to say BC over what? We are going to say BC over, in this triangle, because these triangles are similar to one another, in this triangle, BC is opposite to this arc, to this angle. Now we are moving to this triangle to determine the side which is opposite to the same angle. We have the same angle which is the same as angle D, but which side is opposite to this angle is DC, meaning we're going to say BC over DC. Why? Because they are opposite to the same angles, okay? And therefore is equals to, because that's what we are looking for. In this side, we're going to use this side because it has magnitude, which is side DC. And therefore we are going to say DC over what? DC is opposite to thick. So we want angle thick on the other side, meaning it's supposed to be over an AC, all right? So now why did I use this proportion? Because triangle DBC is similar to triangle ADC. That's why I use this proportion. Okay, now let us substitute. What is the magnitude of BC? That's what we are basically looking for. And therefore, what is the magnitude of DC? DC is equals to 4, is equals to, what is the magnitude of DC? Most definitely is equals to 4. Sorry about that. Is equals to 4. Divide by, what is the magnitude of AC? AC, remember from your diagram, AC, it is made up by AB plus BC, meaning AC, remember AB is 6, so you are going to say 6 plus BC. Can you see that? Now let us cross multiply to solve for B algebraic math. So about that, 6 multiplied by BC multiplied by BC is gonna be BC squared. BC multiplied by that, it's gonna be 6 BC, and therefore 4 multiplied by 4 is gonna be 16, and therefore we're gonna have BC squared plus 6 BC. We transpose 16 to the other side of the equation, we left with 0, and therefore this is quadratic. Let us solve for BC is equals to 0. The factors of BC squared is BC, and BC, the factors of 16, when we add them or when we subtract them, we're supposed to get the middle term, meaning it's gonna be 8 and 2, right? And therefore 8 is going to take the positive number sign, and then 2 is going to take the negative number. Therefore BC in this case is equals to 2. We can't take negative 8 because BC is not supposed to be negative length, so we're going to say BC is equals to 2 units, okay, for 6 marks. That's how we calculate BC from this triangle, which is question number 2.2 for 6 marks. Now we know the magnitude of BC in this case, meaning BC is equals to 2 units, okay? Now let us move on to question number 9.2.3. 9.2.3 for only 4 marks, it says to us, if triangle DEC is similar to triangle AFC, show that CE is equals to EF. If triangle DEC DEC. Can we see this triangle that we are talking about? This triangle right here. If this triangle is similar to triangle AFC, triangle AFC, oh, this triangle right here is actually similar to this triangle right there. We are told that we're supposed to show that CE is equals to FE. Where is CE located? CE is located on that triangle that they have just told us about, DEC. CE, that's where it is located, is equals to EF, and therefore where is EF? There is EF actually located. And by the way, EF, it is also located on a triangle that we were told about, or it's similar to the other triangle, which is triangle AFC. Once more again, make sure that for the fact that you are told these triangles are similar, you're supposed to know they are similar by which angles, okay? Like DEC, like I said, angle C1 is going to be equals to angle C2 because we were told that the bisector of angle C, meaning this line is a bisector, it cuts angle C into two equal angles. So that means angle C1 from triangle DEC is the same as angle C2 from triangle AFC. Okay, that's similar. And therefore another angle is that from triangle DEC, we said that earlier on angle D1 is equals to angle A from triangle AFC. That means angle F2 from triangle AFC is going to be equals to angle E4 from triangle DEC. Hence why they say to you these triangles are similar to one another, and then show this. Now for the fact that these triangles are similar to one another, again, once more, let us extract those triangles. So DEC, we have this, that, we're gonna call this D, this is E, this is C, and therefore we have this triangle which is AFC. We're gonna say AFC is this, AFC, we have A, we have F, and we have C, okay, AFC. Remember we said that angle D1 from triangle DEC, angle D1 is equals to angle A, and this angle right here is the same as this angle right there, and therefore we said that angle C1 is equals to angle C2 from this triangle to that triangle. We said angle C1 is equals to, let me use two lines to arc because that is 1 is equals to that, and therefore let's call this X, that means this, it is going to be equals to that. Okay, now remember we are actually required to show that CE is equals to EF. Like I said, CE is located on this triangle that is similar to this triangle, and therefore EF is also located on this triangle which is called triangle AFC, just that it is located in a weird way, meaning it is located on the side FC. Okay, it's located on the side FC. There we have E, and therefore that will be EF. Now to show this for 4 marks, we're going to use proportional theorem, okay, that these triangles are divided into the same proportion. It's very simple. Once more again, now remember DEC, CD is 4, and therefore DEC, we don't know the magnitude of this side because that's what you're looking for, which is CE, which is CE, and therefore on this triangle AFC, we know AC, the magnitude of AC. The magnitude of AC is going to be 6 plus 2. The one that we have just determined above, which is BC, is going to be 8 because it's 6 plus 2. Again, we said BC is 2. That means AB is 6. That means 6 plus 2 is going to give us 8, right? Now, because we are looking for CE, I'm going to say from this triangle, I'm going to say CE over, remember CE is opposite to angle D, which has only single arc. Now in this triangle we are looking for angle that has a single arc. There is an angle within a single arc, so meaning we are going to say CE over CF, right, is equals to Now we have this magnitude of CD. We're going to utilize the magnitude of that side of a triangle, which is CD. We're going to say CD over, remember, CD is opposite to angle X, and therefore in this triangle, where is angle X? There is angle X, meaning it's going to be opposite to this side, meaning we're going to say CD over CA. Okay, now let us substitute our values. Remember, we want to show that C is equals to EF, and therefore already we have CE onto our equation. Now we are going to say CE over CF. Where is CF? CF is on this triangle. Let's go back to our diagram. This is where CF is, okay? CF, it is actually made up of CE plus EF, which is what we are looking for. So meaning CF, which is this side, it is made up of what? Of CE plus EF is equals to CD. CD is how much? Remember we said that CD is 4 units. Divide by CA. CA is how much? CA is 8 units. And therefore now let's cross multiply. 8 multiplied by CE is 8 CE is equals to 4 multiplied by the whole expression is 4 into CE plus EF, and when you close the bracket, we divide both sides by 4. As we divide by 4, here we're gonna left with 2 CE is equals to CE plus EF, and therefore we transpose CE to the other side of the equation. Now we left with CE to be equals to EF for 4 marks. So this is what you were required to prove, which was question number 9.2.3.